Ever since man discovered crude oil and its endless potential, we have enriched our lives with an infinite amount of products. Most of it comes from the bulk chemical industry, which produces millions of tons of chemicals per year, ranging from paint and plastics to synthetic rubbers, fibres and other materials. For the carbon demand of the chemicals and materials sector, there is only one alternative to fossil resources, and that's biomass. With its huge claim on our planet's resources, the bulk industry turning to this renewable and environmentally friendly feedstock would greatly reduce our environmental footprint. Such a bio-based economy is already starting to become reality. Waste from the paper industry, sugar beet pulp, wood pellets, wheat straw, maize stalks, non-edible crops like miscanthus, and other non-food biomass streams all contain lignocellulose, a tight mix of cellulose, hemicellulose and lignin. These components make a good starting point for many widely used building blocks in the bulk chemical sector. Lignocellulose is abundant and cheap, and it requires new methods to unravel its potential. Chemists in the Dutch research programme CatchBio are developing just that.
Basically, lignin at the moment is just being burnt. The reason is that it's very difficult to convert lignin into something valuable. Lignin has been designed to give strength to plants and to have sort of self-healing properties. So nature has invested a lot of energy in making lignin what we call very recalcitrant, so difficult to convert, and we're trying to go the other way. So that is the challenge that we face.
Lignocellulose consists of a mix of the tightly bound molecular structures cellulose, hemicellulose and lignin. Within the CatchBio consortium, chemists work on new routes to convert these components of lignocellulose into a variety of chemicals using chemocatalysis as their key technology. How does it work? The first step is to break down the woody structure of the plant cells in a cheap and effective way, at low temperatures, with a high yield and without residues. After years of research, this can now be done by using a solvent consisting of cheap, biorenewable ethanol and water. The result of cracking the lignocellulose is a large pool of many different molecules. Out of this pool, chemists can extract and compose new molecules by means of chemocatalysis. In this chemical process, a catalyst increases the reaction rate, reduces the energy required for the chemical reaction, and determines which product is formed. And because the catalyst itself is regenerated, it can be reused over and over again. In this way, chemocatalysts convert biomass resources into a diversity of conventional or even better building blocks. These can be used in the bulk industry to create the same or even better everyday products.
It will affect the daily lives of people in such a way that they will be able to buy the same products that they can buy nowadays, use the same plastics, the same polymers, the same drugs, the same anything that you buy in the store today, but now made from renewable resources. So the chemical industry becoming green means that everyday products will become green.
Being a public-private consortium, CatchBio unites universities in and outside the Netherlands, research institutes and the chemical industry in their quest for bio-based production processes.
Being part of CatchBio really allows us to get much better access to R&D that's taking place at universities and knowledge institutes in the Netherlands to get access to what they can do and what they can provide. Now, the universities come in basically to unlock the feedstock or to look at co-products or other products that we're making. So in that sense, it's really something that is very complementary. It makes actually a very good fit for us to advance our technology.
CatchBio researchers are developing biomass conversion processes which can rely as much as possible on existing infrastructure. This cost-effective advantage is an important driver to make the transition to a biomass-based society really happen. It makes the biomass-based economy no longer an idealistic perspective, but it creates a new exciting market with new economic opportunities.
Avantium signed joint development agreements with the Coca-Cola company and with Danone for the development of 100% plant-based PEF bottles. Both companies are really very interested in bringing 100% plant-based bottles to the market. They see that consumers are really sensitive and are asking for materials that are not made from petroleum but that are renewable. The nice thing of our PEF bottles is that they are 10 times better in keeping the oxygen out of the bottle. They're 5 times better in keeping the carbon dioxide, so the sparkling part, in the bottle. And it's also better in keeping the water in the bottle. So they really have a benefit.
Partners in CatchBio are building our future prosperity by utilising biomass as an affordable, reliable and clean resource for almost any everyday consumer product we can think of.
For me, there is no doubt that the bio-based economy is the future for this country, and I think it will provide tremendous opportunity for existing players, but also really for new companies that are emerging in this area.